All right, class, so this video is going to be going through the second assignment of the week. It is on the second topic in which we're determining solutions of quadratic and linear inequalities. During this topic, we see a lot of different shadings, and our whole goal is to figure out where a common solution will be. As we've learned about earlier when we were dealing with linear inequalities at the beginning of the year, we knew that common solution area, also known as that feasible region, is where all of our shading overlaps. So we're going to go through this assignment. This assignment, once again, is on PM students. It is a practice assignment. This is going to help you get really geared towards your assessment, which is due by the end of the week. Okay, so the first question, it says, given the linear and quadratic system of inequalities, determine which point is a solution to the system represented by the following inequalities. So it gives us our graph here of our functions. It gives us our two inequalities. Our first one is a quadratic inequality. I know it's quadratic because it has an x, or it has the negative 2x squared. And then I also have a linear function because it just has an x variable here that's written in the form y equals mx plus b, that slope-intercept form. They already did the shading for us. They already graphed it. Our whole goal is to figure out where a solution to the system is going to be. So once again, a solution is going to be where both of my shadings are going to overlap. So as you can tell, my quadratic here, it is a less than or equal to symbol, so it's shaded inside of my quadratic function. And then my linear function right here is in blue, and it's greater than or equal to, so it is shaded above the line. So after we get done shading, we see that this is the common area where both of our shadings overlap. So I'm going to kind of make that stand out a little bit more on my paper here. All right, so basically any point that I can find in this black shaded area is going to be a solution to not only the quadratic, but also to the linear function. So let's go down here and let's look at our given points down here. It's a multiple choice question. So negative 7, 1, that means I'm going to the left 7. It looks like it's going up by 2, so 2, 4, 6, 7, and a positive 1, which is like right here. So clearly that point is not in my shaded area, so right off the bat, I can cross off that example. Negative 4, negative 1, negative 4, and then negative 1 looks to be right here. That is in my shaded area, so that is definitely a solution. Some of these PM student questions, there's more than one right answer, so I'm going to keep going just to make sure none of these are correct as well. So we have a negative 4, negative 3, so go left to negative 4 and then go down to negative 3, which is right here. So that one clearly not in my double shaded area. And then 0, negative 4 looks to be right here, which once again is not in that shaded area. So once again, a solution is where you find a point that is in the double shaded area known as that feasible region. All right, moving on. Question number 2. Very similar question here, except for it doesn't have the shading done for us. So let me straighten my papers here for a second. Okay. It says, given the linear and quadratic system, determine which point is a solution to the system represented by the following inequalities. So literally the exact same question. The equations are different here. However, our shading is not already done for us. So we want to look and we want to shade both of these separately. We want to figure out where those shadings overlap, and then just like question 1, figure out which point is in both of those shadings. So let's look at the quadratic first. I'm going to do it in blue. If you viewed the county video, the way they like to do this is they like to pick a point. If the point is, and when you plug the point into the inequality, if it makes a true statement, you shade over top of that point. If it makes a false statement, you shade away from that point. So in the video, Ms. Goldstrahl picked the origin 0, 0. So I'm going to pick the origin 0, 0. I'm going to plug it into this quadratic right here, and I'm going to see, is it going to make a true or a false statement? So I'm going to do that work right up here. We have y is less than or equal to negative x squared plus 6x minus 6. I'm going to plug in the point 0, 0 for both x and y. And I'm trying to figure out, is this going to be a true or a false statement? All right, remember when you plug values in, you always put them in parentheses. Everything else stays the same except for the variables. All right, so can't really do anything to that left side. 0 times 0, so 0 squared is 0. 0 times a negative 1 is 0, so this whole thing turns into 0. 6 times 0 is 0, and then this negative 6 is still chilling outside. All right, this simplifies down. 0 plus 0 minus 6 is a negative 6. So our question is Is 0 less than or equal to -6? That answer is no, right? 0 is greater than -6, so it's a false statement, which means we shade away from the point. What that means is, instead of shading everything over top of the point on the outside of my parabola, I'm going to shade on the inside of my parabola, away from the point. All right, so draw a bunch of little lines there. All right, it helps if you do this on a separate sheet of paper and you're using different colors. That's always beneficial. All right, next I'm going to now deal with the linear function. I'm going to pick the exact same point, the origin. All right, so come down here. I'm going to show my work at the bottom here. I'm going to write my equation out, 5/4 x plus 4. I'm plugging in that point 0, 0 to check. All right, this looks scary because I have a fraction, but the good news is, since I picked a nice point 0, 0, this is just going to turn into 0. 0 plus 4 is 4. Is 0 less than or equal to 4? That answer is yes, which means it is true, which means we are going to shade over top of the point that I just selected. So coming back up here, you guys all see my linear function right here. Since it's true, I'm going to shade everything over top of that point. So that is on this side of the line. Remember, the part that you truly care about is the part where all of your shading overlaps. So in this little segment right here, I have both blue and red. So any point that falls in this black area, just destroying all my Sharpies, in that black area is going to be a solution to the system of inequality. So now let's come down here and let's check our answer. So the point 1, 1, 1, 1 is right here. Therefore, it is not in that black shaded area. So I can get rid of 1, 1. All right, 3, -2. Over 3, down 2. That point does fall in that black area, so that is definitely a solution. All right, let's go and check the other ones. 4, 1. 4, 1 is up here. 4, 1, so not in my shaded area, so cross that guy off. And then 6, 1. 6, 1 is right here, also not in that dark shaded area. So the answer is 3 and -2. If you look on Google Classroom, we've also shared a helpful guide that is going to help you with this shading a little bit more if you are still struggling with that. All right, moving on. Question number 3. It is literally the exact same question, except for it is new inequalities. All right, so once again, it says, given the linear and quadratic system, determine which point is a solution to the system represented by the following inequalities when the graphs are shaded. So it already gives me my graphs. I just got to figure out where the shading is and then pick a point. So the bad news about this one is 0, 0 actually goes through the linear equation. So we're not going to be able to pick 0, 0 for my linear function down here. I'm going to try to give you a little shortcut on that one. But the good news is 0, 0 does not go through the quadratic. So I'm going to still use that to determine if I'm shading inside or outside of my parabola. All right, so y is less than or equal to a -x squared minus 8x minus 14. I'm using the point 0, 0. Plug it in. 0 squared minus 8 times 0 minus 14. All right, these are just going to get, this is going to be 0, this is going to be 0, so I'm left with a -14. And then is 0 less than or equal to a -14? That answer is no. It's a false statement. Therefore, I shade away from the point. So instead of shading over top of the point and around, I'm going to shade inside of my parabola. All right, there we go. And then now for my linear function, like I said, I cannot use the point 0, 0 because it goes through it. So you can either pick another point. So we can pick like this point. So let's pick the point 0, 1, and I can plug that in. And I get, so this is my x and my y value. My y is 1, and then my x is 0. Is 1 greater than or equal to 0? That answer is yes, so it's true. So we're going to shade over top of the point. So I'm shading all of this. I'm shading over top of the point that I selected. See how my mark goes right over that point? And then, as always, we care about where that shading overlaps. We see blue and purple in this area. So this is my feasible region, right? The solution set. And let's go down and look at these points now. So 0, -2. 0, -2 is right here, and it is not in my shaded area, so that is not a solution. -3, -6 is right here, and not in my solution set, not in my feasible region. -5 and -2 looks to be pretty solid, right? It's directly right there in that black shaded area. And then lastly, -8 and 1, -8 and a +1 is right here and not in my set. All right, guys, I am going to leave you guys to do question 4 on your own. It is very, 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 very similar. You just got to figure out where to shade, where the solution set is, and which of these points is the solution. Obviously, I want you guys to do this so I can provide feedback for you. Let's look at question number 5, the last question here. It says it's an error analysis question. So it says a classmate graphed the system of inequalities and concluded that because the shaded regions do not intersect, there are no solutions to the system. Describe and correct the error and then determine the number of solutions. Okay, so we want to check a couple of things here. We want to make sure our shading is correct. If you look at the sheet that we posted there with the correct shading, if we have this right here and we're dealing with the parabola, if it is a positive a value, as in it's facing up like a smiley face, if you're positive, you're smiling, and it's greater than or equal to, you are going to shade inside. So that one seems to be correct, right? Use that reference guide to help you answer this one. Let's look at the linear function here. Right, this is my linear function, looks pretty solid there. It is a hyphenated line because it's just a greater than symbol. We want to check to see if that shading is correct. So let's pick the point 0, 0 because 0, 0 is not on my line, and let's test it out. All right, so I'm using this equation. All right, I'm plugging in the point 0, 0 to check my workout. 2/3 times 0 minus 4. And I get 0 is greater than a -4, which is true, right? Since it's true, I want to shade over top the point that I picked. All right, so they shaded below the line. We should have shaded above the line. All right, so it says describe and correct the error. So the shading was incorrect. So shading was wrong for the linear inequality. It was wrong for the linear inequality. And we wanted to shade above, so we corrected that. We already did that. And then lastly, it says determine the number of solutions. So this parabola doesn't just magically stop right here. It's going to keep going up forever. Same thing with these blue shadings. So the number of solutions here is going to be an infinite number of solutions. So number of solutions is an infinite number of solutions. All right, guys, make sure you check out all of the videos that we've posted prior to taking your assessment. The more work that you put in prior, the better your test scores are going to be. Please email me or call me or text me with any questions you may have. See ya.